Paul.
I reassure colleagues that I haven't done a single tweet so far, well, about the conference anyway. There's one of my favorite authors is a guy called Richard Florida, who wrote a book called The Rise of the Creative Class. And if you follow him on Twitter, he's quite a prolific Twitter and retweeter. Anyway, this morning he was tweeting about Obama's speech, and he managed to get language wrong. Obama, in his speech this morning in Chicago, said, I have never seen more hope for the United States than today. I have more hope for the United States today. And Florida forgot the word more in his quote. So Obama was quoted by Florida as saying, I have no hope. Little words really do matter. And I will return to this morning's decisions in a couple of slides. I wear two hats. Land Quality Management Limited is 15 years old this year. It's very convenient that my eldest son was born in the same year as LQM, which means I can remember how old they both are. But we do all sorts of interesting stuff. And the day job is running a master's at the University of Nottingham and doing research, supervising PhDs. And I did put the list of the members of the DEFRA panel on this slide because I'm very proud of the fact that 3 out of those names are alumni of the master's course. Sarah Ray, Anne Barker, and Liz Hamer all suffered and survived the master's course at Nottingham and have gone on to bigger and better things. I'm not going to give you an outline because then you know what to expect. But I wanted to begin by looking at effective risk assessment and say I very much enjoyed and endorsed Phil's comments before the coffee break. I'm currently in the middle of teaching a module on contaminated land to environmental management master's students. And you cannot manage something that you have not first understood. And site characterization is part of that process of understanding. If you don't understand something, how on earth are you going to make sensible decisions? Risk assessment is all about making a decision about to remediate or not to remediate. I usually apologize to Shakespeare at that point, but I don't think Shakespeare and the Institution of Civil Engineers have much in common. I'm a Philistine geologist, so I can say those sorts of things. But risk assessment is about making a choice. Do I need to intervene or don't I? And I want to use the word risk very precisely as well. Obama, you can tell I've kind of been following the election, but this slide is a couple of weeks old because we had to give our slides in early. And Obama tweeted that if you're going to throw an all-nighter, it's my typo, not his, where better to be than in Las Vegas? So risk is associated with gambling, perhaps. It's also used as a synonym for probability. The risk of rain, the risk of whatever. But I want to talk about it in terms of hazard, the presence of contaminants in the ground, and vulnerability, the exposure and consequences of someone or something coming into contact with that hazard. That's the phrase, the concept of risk that I'm talking about this morning. Now, decision making is not about getting it right, because if you try and get things right, occasionally you'll get them wrong. Now, if you're doing archery and you aim for the gold bit in the middle and you get it wrong, it doesn't matter which way wrong you are, you still get some points. But if you're William Tell and you're aiming at the apple and you're a bit high, that's kind of okay, you've just missed the apple. If you're a bit low, then you are in deep trouble with Mrs. Tell back home. You see the principle here. Now, in decision making, a type 1 error is where you make a false positive. You wrongly say there is a problem when you shouldn't have done, and that results in unnecessary remediation. We kind of want to do a little bit of that, because a type 2 error is where you wrongly say the land is okay and you really should have done something about it. Now, the art is to do as little unnecessary remediation as possible without leaving behind problems that are going to cause significant harm and all the rest of it. So that's the context within which decision-making takes place. Headline article in one of the local newspapers in the States, Army Corps removes soil with high arsenic levels. Great! The Army Corps of Engineers removed the last elevated levels of arsenic from a particular street. They were digging out arsenic at 22.8 parts per million. We heard from David first thing this morning that the normal background concentration away from mineralization and so on is 32. The soil guideline value is 32. These guys, and it made the news, were digging out at 5 feet, sorry, that's about 1.6 meters, an area of 4 foot by 4 foot. Why? And we'll look at that a bit later on. Background in the United States is well understood. Paper here by Vosnakis a couple of years ago, Vosnakis et al. A couple of years ago, and they looked at a number of American states, and they concluded that remediation to risk-based screening levels can be costly and may not be warranted where site concentrations are similar to background levels. Too right, 22 mg per kilogram? Why? And in a few slides' time, I will look at what we do on this side of the pond. Now, smart risk assessment, which is really what this talk is hopefully about, and I mean smart in the acronym sense, is all about asking the right question and then answering it. And the right question is the legal context. So if you come and chat to me and say, I've got a site and I'm doing X, Y, Z, my first question will usually be, hello, my name's Paul, who are you? But the real question I want to ask is, what's the legal context? Are you doing this under Part 2A or planning? Which country are we in? There are at least 4 in the United Kingdom, and they've all got their own legal contexts. So that determines the decision I'm trying to make, the basis of that decision. Is it Part 2A? Am I high jumping over a high level of risk? Or is it planning? Am I limbo dancing under a low level of risk to prove, as the NPPF requires, that the site is safe and suitable for use? Then you go down through all the stages of risk assessment that require the kind of characterization that Phil shared with us. Now, risk-based land management breaks down into 4 different categories. The upper one is looking at old, legacy-type contamination, and then the bottom 2 categories there are for new contamination. Part 2A sits top left-hand corner, historic contamination, ongoing land use. Planning, top right-hand corner, we're changing the land use. We need to demonstrate that the land is now safe and suitable for use, for the new use. And those are the 2 areas I'm really going to dwell on. I'm not going to touch on the other 2 in this talk. I'm going to use a little bit of historic, anachronistic language in my next slide, and I apologize in advance for that. But I'm a geologist, and this is the soil world. This is the kind of world that we go and take samples in. We analyze them either on site or back in the laboratory. We push things into the ground to try and understand what's going on. And in the soil world, we've already heard this from David, that Part 2A is about identifying and removing risk that is going to cause bad stuff if we do nothing about it. Now, Part 2A calls that unacceptable risk. The planning guidance also refers to unacceptable risk, but it means something else. So in Part 2A terms, we're wanting to find unacceptable risk, and we'll look at that in a minute, and then remove it. Under planning, we're looking to demonstrate safety and suitable for use. We're looking at a tolerable, minimal level of risk, so safe as houses, if you like. And the kind of accelerated form of risk assessment we use, the assessment criteria, the Rolls-Royce value, if you like, the gold standard is the soil guideline value produced by the Environment Agency for about 10 substances. We worked in partnership with the Chartered Institute of Environmental Health and ran a couple of public workshop exercises to develop generic assessment criteria for about another 80-odd substances. And now the C4SLs that David introduced and a couple of you are working on in the audience are there to help us make slightly less conservative decisions. So if you remember my type 1 and type 2 errors, we still want to make sure that we're not leaving behind unacceptable risks. But we're getting kind of closer to the edge. Now, in the human world, again, it's a little bit more interesting. This is the world of the toxicologist and the epidemiologists and the medical sciences. And this is where I've used the colours, because that's kind of how the diagrams were created, but the phrases of green and amber red and so on are language that was used in early drafts of what became the statutory guidance. Categories 1 and 2 are those that pose a significant possibility of significant harm. Intervention is warranted. Category 3 poses a non-trivial, not low level of risk. And Category 4 has a spectrum from no risk right the way through to the upper ends of low level of risk. But that's the kind of it can't be contaminated land. Now, where are the boundaries? We know at the moment where the boundaries in human world, they are between Categories 3 and 4. We've kind of made those decisions as a society. We don't know where they are in the soil world. What we don't know in the human world is where the boundary between Category 3 and 2 is. That line, at what level is an intake unacceptable? At what level do you suddenly switch from I'm not going to regulate to I am, is not one that the toxicologists are willing or perhaps even funded to answer for us. And we'll come back to how we could answer that question towards the end. Now, remediation is about demonstrably breaking the contaminant pathway receptor linkage, removing the unacceptable risk, however that's defined in your legal context, and making sure the land is safe and suitable for use. It could also be, and this may echo back to the questions about where do you clean up to, how far future-proof, how far do you go in terms of future-proofing your remediation? It could be a desire to remove corporate liability, to take out any latent liabilities under FRS 12, or if you're an American company, Sarbanes-Oxley, and so on. Most remediation in this country is carried out to enable the redevelopment of what I call brownfield sites. Derelict, abandoned, underused, former factories, that kind of stuff. Most of that land is in cities, and cities seem to be where more and more of us are living. The trends worldwide is that a higher and higher proportion of people live in these things we call cities. More than half the world's population now lives in cities. Now, if you look at a city as a system that has a variety of functions, and you look at those in terms of their environmental, social, economic, and governance models, you can then look at brownfield redevelopment as a system perturbation. How will London change when Crossrail is opened? I came in on the Jubilee line this morning. We know what the Jubilee line did to house prices along the line close to the stations. So how does a system respond to brownfield redevelopment perturbations? And is that a smart change, one that helps things become better, more sustainable, if you will, or not? Now, I'm using the Cabernet definition of brownfield. One of my PhD students, a Taiwanese student, her entire PhD thesis was about the policy ramifications of your definition of brownfield. Fantastic piece of work by Yu-Ting Tang. She's now just become an assistant professor at the University of Nottingham, in China campus in Ningbo. And this is a paper in the open access literature if you want to look at that. I was amazed we were allowed to keep the title of Sticks and Stones, if you know the childhood rhyme, but that went through the entire peer review process, and there it goes. But brownfields, defined by Cabernet as former uses of the land having affected the site, derelict and underused, etc., etc. The key thing here is that the contamination isn't an essential prerequisite for a land to be brownfield, unlike in the United States. But the land has to be derelict and underused, so any previously developed land, the language that's used in this country, isn't necessarily brownfield in that sense. That definition, that concept has been adopted by the World Bank, and it's been adopted by European funding organizations to try and help inform investment decisions, to try and identify those sites where a little bit of extra help can tip a project from wouldn't touch it with a barge pole to, yeah, this is going to fly. And if you're not familiar with the work of the Cabernet network and the ABC model, which was also adopted by English Partnerships a few years ago, so it has echoes into this country, then I would suggest you look at that work, again, available online. And if you're working at international funding projects, as I believe many UK organisations should be, because what we're doing here is really good ways of looking at chemically challenged land, then have a look at that work. Now, the ABC model is all about identifying the A sites, the ones where profit is to be made. and looking at the boundaries and realizing that those boundaries can be shifted either by policy or by better data gathering and data collection and better understanding. You can shift your sites out of loss and into profit by understanding the mechanics beneath this model. Remediation is not an island. Remediation is not always, or indeed often, the end game. Regeneration, which I've used Gordon Brown's definition about people, turning around deprived communities, is really what we're about. The egg timer that Clive will start shaking at me is wrongly labelled the Baseford Regeneration Project. Baseford wasn't regenerated. Baseford was remediated. The site is still empty, unused, while they argue about what to do with it. Redevelopment is about building new stuff, the new buildings, the infrastructure, and so on. Remediation is about dealing with the chemicals, the risks associated with those chemicals. And if we're going to embed remediation into redevelopment to engineer and bring about regeneration, then it's the sustainability of the regeneration, or if you want to draw your boundary at the point of construction, then the sustainability of the redevelopment that we should be looking at, not just the work of the remediation engineers. And that's recognized by the Sustainable Remediation Forum by SURF, who have just submitted a paper looking at the interactions between remediation and reuse in a sustainability framework. The planning policy framework talks about safe, suitable for use, and so on, and we'll unpack what that means in a minute. Let's go back to my American Corps of Engineer friends and look at what's happened in this country. Some of this data is the work that David introduced us to from the BGS. I was a part of that project team, but BGS did all the good, clever, exciting stuff and rightly get the credit for it. But in this country, we wouldn't look at a value of 22 and say we need to do something about it. Don't need to worry. Look at the work we did on the Avenue Coking Works for a particular material, and we started looking at the site-specific bioaccessibility, at the site-specific plant uptake values, and there we were able to show that not just 32 milligrams per kilogram was safe and suitable for use, but as high as over 100 milligrams per kilogram was safe and suitable for use, which then allowed a huge volume of one particular material to be used on site rather than to be treated as contaminated and as a problem. So we turned a waste into a resource. We tried to do the same with benzoate-pyrene, same kind of level of sophistication and so on, but we couldn't demonstrate that for one particular material that would be the case. We managed to come up with higher assessment criteria, but that wasn't good enough to demonstrate that a particular chunk of material there was okay. But we have good, reasonable, normal background concentrations for the urban areas of about 4 milligrams per kilogram. That kind of feels sensible, it feels right, it's in accordance with other numbers that we have out in the literature. So we're pushing beyond generic assumptions, we're using better information and converting that into intelligence by looking at it under a legal context. We don't always get it right, and this is a planning permission, an extract from a planning permission from August this year, so post-NPPF, post-National Planning Policy Framework, which talks in a very linear fashion about the need to characterize the site and then develop a conceptual model and then come up with a remediation project and then think about the redevelopment. Massive sequence of conditions for a tiny site on which one house was going to be built. The solution here was to go and talk to the engineering consultant who's going to design the house and say, just design the whole shebang. House, foundations, membrane, everything else in one go, and engineer the risk rather than spending lots and lots of money trying to characterize something for one property, where actually you knew pretty well from the kind of information you get from Landmark what the issues were going to be. So you kind of need smart regulatory requirements to help us along. A linear approach, as Phil told us earlier on, is a good way of wasting money. You've got to think on your feet, be flight of foot, and respond to emerging situations and emerging information if you're going to make good decisions. I've talked about high jumps and limbo dancing. I was in the Olympic Stadium over the summer on the day they awarded 3 bronze medals, and I chatted to the guy who was responsible for the medal ceremonies about how they were going to sort that out. with the flags and so on. If you want to find out the answer, grab me at lunchtime. Now, how do we find that boundary between 2 and 3? How do we know whether a site is significant in Part 2A terms or not? Well, category 0, it doesn't exist in the stat guidance, but significant harm is defined, unfortunately, through work carried out by FERA, funded by DEFRA. It doesn't seem to be particularly common in the United Kingdom. It does happen elsewhere, sadly. If you look at the arsenic-related deaths in Chile, for example, we do have contaminants causing significant harm, fortunately not within this country. Category 1, the criterion, and I've put the key words in bold, is conditions which are supported by robust science-based evidence that significant harm would occur if no action is taken to stop it. If you don't determine and remediate, bad stuff will happen. Category 4, don't get out of bed. It's perfectly okay. There's no linkage. You've only got normal levels of contamination. You don't exceed relevant assessment criteria. And category D intrigues me. The levels of exposure are likely to form only a small proportion of what a receptor might be exposed to anyway. 2 and 3 is where all the action is. The starting assumption is that land doesn't pose a significant possibility of significant harm. But the key words here, at bottom left-hand corner of the slide, is the authority considers on the basis of the available evidence, including expert opinion, that there is a strong case for taking action under Part 2A on a precautionary basis. The pain, the hassle, the disruption, everything else of doing remediation is outweighed by the benefits. It's a price worth paying, and the price in environmental, social, and economic terms. If it doesn't, then it ain't category 2, it's category 3. There may not be a 0 or minimal or low level of risk, but it's not enough for us to intervene. And there is a thin sliver of sustainability appraisal, which I won't talk about too much. The tool that we've developed to try and resolve whether you're in categories 1 and 2 or 3 or 4 is to look at the entire scientific data set we have about contaminants and plot them all on a common axis, and we've called this the dose response cloud. We're now starting to see the use of this tool specified in local authority tender documents. Quite cool, really. The idea here is to move beyond subjective numbers like the health criterion value, like the no observed and lowest observed adverse effect level, and go back to the raw science. To try and echo explicitly the language used in the stat guidance for what means category 1 and 2. Remember, the starting assumption is the land is not contaminated unless it is. Historically, and we've heard this morning, the contaminated land sector has asked the wrong questions in Part 2A. It said, how far over a soil guideline value do I need to be before I determine? Same question is, how far over a health criterion value, a negligible, minimal level of risk tox value do I need to be before I determine? They're the wrong questions. The bar is very high. The bar is significant harm. The bar is if you do nothing, somebody will suffer. The HCVs and the SGVs they're based on are down here. They're limbo bar height. So the roadmaps, substance by substance, are very simple to use. They're just an Excel spreadsheet onto which you superimpose your site data. It took us a lot of time to produce them, but in terms of using them and understanding with them, they're very, very clear. We've now used them on sites in England, in Wales, in Scotland. There are about 30 organisations licensed to use them across the country, and they are really helping shed light on why land, which may have a history of contaminative uses, actually doesn't meet the tests for Part 2A. And if you know your law well enough, you'll know that Scotland is still working under the old unacceptable intake definition of SPOSH, whereas England and Wales have now moved on to the categories 1, 2, 3, and 4. So this stuff was conceived and developed under the old regime, and it works even better, I have to say, under the new regime. So what is smart risk-based land management? Well, it's site-specific. Phil and I could have coordinated our talks, but the better you understand your site, the less over-conservative you have to be. Go back to type 1 and type 2. Ooh, that's good. How much have I got in there?
2 minutes.
2 minutes, that's cool. has to be measured. You need to use a variety of lines of evidence to overcome all the uncertainties, both natural and through our lack of knowledge. The aleatory and epistemic, if you know your Greenleaf's 3. There are always boundaries, there are always limits of time and money and space and so on, so whatever you're doing has to be achievable. And it has to be couched within a good understanding of the legal context, the business case, and whatever the other constraints that the project itself brings to the game. And then finally, there is a time element on this. All land is used time and again in this densely populated island of ours. If you look at going back to Sandy last week, if you look at the shoreline of Manhattan Island at the time that it was originally occupied, and you look at the shoreline today, and you look at the areas that were evacuated or devastated by Sandy, it's all the land that we create, well, not we, but were created. It's all the reclaimed land that really suffered. So land use, in the way that we have it in this country, where we reuse our land time and time again, means that we shouldn't only be designing and assessing for the current and the next land use, but thinking of the one after that as well. Designing today with the next land use in mind. And that's the subject of a European project that we're involved in, to try and look at how you would do that in a pragmatic, real sense way. So I'm going to close there by kind of echoing some of the things we've already heard and leading us hopefully into some of the things we're going to hear in the subsequent talks. I haven't tweeted yet, but if you want to follow, then the Twitter account is there. If you want to continue the conversation, then grab a card or email me at this address. And if you want to engage with the broader blogosphere, it's not a blogosphere, I'll talk to him afterwards, that Clive introduces to, then a UK forum is the Contaminated Land Strategies email forum through the JISCmail framework. About 2,500 people there, exchanging all sorts of ideas, good and bad. And if you've got an international, global interest, then the LinkedIn forum on contaminated land management has about 3,000 people there from all countries around the world. It's a good place to find out what's going on across the globe as well. So thank you very much indeed, and thank you for the invitation.
Thank you, Paul.